Hello everyone, welcome to this lesson. Today we're going to be learning about objects and classes. This is where coding becomes actual coding. This is going to be epic. All right, so yeah, this is where coding becomes coding because we get to make anything we want at this point. So instead of me describing it, let's actually just go ahead and do it. So what is an object? All right. Well, an object is like an object in real life, right? Or an object in code is like an object in real life. An object, right, in real life has properties like stuff you can observe, and the object also has functions, right? You could do something with that object. And the example here I have is of a pencil, right? The pencil, right, has the property of a color, and that color is actually yellow. It also has the property of the length, and the length is 8, right? 8 inches, whatever we want, and also it has one more. It has a function. We can write something with a pencil. So let's hop into the playcode.io, our favorite IDE, and actually code it. So making an object is just like making it's just like making a variable, right? So you can say let pencil equals, right? And instead of square brackets or parentheses, we use curly brackets, right? So now we can say the property, right? So we want the color, and then use the colon here. We want the color to be yellow, right? Yellow. You can use capitals, doesn't matter. And then what you add a comma to separate your different properties, and then you have a comma. Enter. Let's give it a second property, length, right? And then let's make it 8, right? And so actually good practice here, instead of just typing color, we want to surround it with quotation marks, right? Now even though it'll work without quotation marks, it's just good practice. It'll help us later on, and I'll show you what I mean. So let's go ahead and type, let's give a function now, and you don't actually have to say function write something, you just type in write something, the name of our function, give it some arguments. I'm just going to have it log something to the console. We wrote something. So how do we actually access this stuff inside of our object now? Well, you just go ahead and type in pencil.color, right? Let's go ahead and log this. Console.log, pencil.color. All right, pencil.color. So you'll see in the console now, it's yellow, right? Another way you can actually access something is to type in these square brackets and then use the quotation marks we used earlier. Color. And so you see it's yellow, right? Now, how do we, now we logged something. How do you actually change one of the values? So you can say pencil.color, right? Or, pencil square brackets with quotation marks color. We set that equal to, let's make it brown, right? Now we have a brown pencil. I didn't log it to the console, that's why the console still says yellow. All right, now what if we want to give our pencil something new? Pencil.erase, sorry. No, let's try, eraser color. Let's set that to white. And we can, just to make sure that our pencil actually has that now, let's go ahead and log our pencil to the console. Bam. Now we have an eraser color. We added something new to our pencil. And now let's try calling out one of the functions. Pencil.write something. Bam. It called the function, we wrote something. And so typically in coding, when we change one of the values, right, or when we talk about one of the properties, right, instead of the functions, I should speak slower. We say pencil square brackets color, right, with quotation marks. But when you use one of the functions, we just go ahead and use the dot there. Now both will work for for the property, and we can actually try typing in pencil square brackets of write something, and you'll notice it'll kind of error out. It doesn't know what to do, so you want to avoid that. But this is the convention. You typically use dot when you're using functions, and then you use square brackets when you're using properties, right? An example of objects that we've been using already is math.squareRoot. Now this is I talked about math being a library, right? But really it's just this huge object, right? It's just this huge object with a bunch of functions inside of them. So we can access the functions using dot. Now where did this object actually come from? Well, it's built in what's called the standard JavaScript library, right? JavaScript, you'll notice that we can use if and for and all of these things because JavaScript they come built into the JavaScript library. Other things like math are also built into the JavaScript library. So yeah, we can use that. That's So what's next? Well, we can also loop through objects, right? Just like actually, let me describe objects in a different way before we start looping through them. And yeah, let me skip this example. I'll just type it out in the code. So when I say we can access objects like a dictionary, right? It's just like this. When we type in let dictionary, let's fly, right? Go up into the air. Oh, no colon there. And our object here is just like a dictionary, right? What is a dictionary? Well, it has a bunch of words and their definitions. In the same way, right, our dictionary in code, right, our object in code has the word and its definition, right, the property and its value. So we can now if you can treat an object like a dictionary, you can kind of loop through your object as well, right? You can go through every word and see what its definition is. So let me create a new object called student IDs. I'm just gonna leave it all undercase for now. Or just, yeah, I'm gonna leave it undercase. Bob. Let's come up with some names. This dude's name is Bob. And so that's his ID number. Let's create another one. Bill Jenkins. Let's try Bill Jenkins. Another ID number, right? So we have two IDs. Actually, we'll add a third, right? Why not? Jim Jar. There you go, Jim Jar. That's his. Okay, Jim. Why do I keep adding semicolons? So this is a set of IDs, right? And we can treat objects like a map, right? Or actually, when I say map, it might be okay. So when I say map, I mean we're mapping one value to another, right? We're mapping essentially names to their IDs, right? We're mapping one type of data to another. That's how people typically describe objects. Or dictionaries. It's mapping the string to this number, right? So how do we actually loop through this now? It's like how we do it is by treating the string or the word, right? In the dictionary, we treat the word as an index, right? And an index, again, it's just the location of something, right? So like on your dictionary, fly is the location of this definition, go up into the air, right? And when let's create a real quick array. Shopping or shop list equals vegetables, veggies, and then candy. So why did I use curly brackets there? Silly Luke. Okay, so the index of each of these items is the location of these items, right? Veggies, the location of the veggies is 0, right? Its index is 0, and then candy is 1, right? So let's review last time. For item of shop list. We'll just go ahead and log the items. Item. And I didn't mention this last time in the arrays lesson, but you don't have to type in for let item. You can just type in for item, and that's because again JavaScript is so adaptable and it's crazy. All right, so you could do this, right? And what is the like equivalent for dictionaries? Well, I'm gonna loop through student IDs now. For student in, instead we're gonna type in for student in student IDs. Let's go ahead and log this. Now you can make a prediction right now. Will student be the student's name or the student's ID? And the answer is it's their name. So what is the difference between in and of, right? Well, let's I guess exemplify it. Let's replace of here with in for item in shopping list, and you get 0 and 1. And you'll notice 0 and 1 are the indexes for the veggies. So in, you'll notice, gets you the indexes. It gets you the names of your object, right? Or the index of your array, right? And then if you want to actually access the value, you type in of. And you'll notice if we try to do of here, it won't work because that's just how JavaScript works. So how do you actually get the values of their names, right? How do you get their IDs? You'd simply type in student IDs of student. And you have to use square brackets here. Using the dot will not work. And that might not make sense. Why can't you use the dot here? You don't have quotation marks. Well, that's because student evaluates to a string, as in student becomes a string. So if we use if we use square brackets here, it's fine if we have a string in there. You're supposed to have a string in there. So you can, again, to loop through an object, you use for student in student IDs, and that gets you the name, right? The actual index. And in order to get the value or the IDs, you use these square brackets, right? So this is the last one. It's a biggie. This is actually a rather short lesson, but that's okay. This is really important. So classes. Let's just hop right into it. I'm gonna explain it as we code. So what is a class? I'm gonna hop all the way down here. So if an object, right, is like an object in real life, what is a class? Well, you can think of a class as like a blueprint, right? So if you want to build an object, right, if you want to construct an object, you can have the blueprint for it, as in what kind of things you want this object to have. And so let's go ahead and create one. Let's say we're creating dogs now, right? And another reason you have a class is so you can create a bunch of objects really quickly, right? So now, let's say we have a dog, right? And then the dog's color, I'm gonna do this again. Color equals brown, right? And then bark, console.log. Oh, wait, okay. Alright, this doesn't work. Okay, I'll explain why this doesn't work later. But, okay. So instead, I'm going to type in constructor. So what is the constructor? Well, you can think of the constructor as the first thing that runs when you build your object, right? So, you're pouring, okay, no, that's a really bad analogy. Okay, you're building your dog, right? What is the first thing you want it to do? Well, you want to first give it some values, right? So I'm going to use this dot, and what I mean by this dot is when I build this new dog, this becomes that new dog, right? This will make more sense later. So this dot color equals brown. All right, and then if you want to give it a function, you don't say this dot, bark equals function. You could do this, right? You could totally do this function. What, bark. All right, but the easier way to do it is to just go down here and under constructor, you type in the name of that new function you want to write. So let's go back here. Let's just log woof, right? So how do you actually create a new dog now? Well, it's easy. Let's call this dog Spot. Yeah, Spot. That's a cool name. All right, and then we'll say new dog, and then parentheses. Okay. So let's analyze this. Let's go through this one line by line. Constructor is the first thing that runs when we create our dog, right? So now our dog has this color called color, and it's brown, right? Excuse me. So we also give it the function bark. You don't type in function here. You just go ahead and say the name of your function. Excuse me. So now if we want to create it, we say let spot equals new dog. Now when you say new dog, you're actually calling on this constructor right here. New dog is this constructor. So what if you wanted to give it a certain color? Well, you would type in color here, right? Or new color, right? And then you would type in new color here, right? And so now you can give your dog a color. I'm going to give it brown. And you can think of why that's useful. Now you can create a new dog, right? Jim. I'm going to create a dog called Jim. And Jim has the color, he's a red dog. I don't know why he's red, but he's red. Clifford. There you go. Okay. So you'll notice here, because I called on the constructor here, right? I called in and I gave it the argument, right? The input of brown. Brown goes into new color, right? It gets stored into new color, and then this dot color, the color of the actual dog, right? Spot's color is now new color, right? It's now brown. So how do we go ahead and see that? Well, we can just log spot.color, and you'll see he's brown. And you can go ahead and log, Clifford's color, and you'll see that it's red. But that's how you do it. That's how you do it. And if you want to, call on one of their functions, you say spot.bark. Bam! Now he woofs. That's so cool. All right. So yes, this is one way. This is how you basically use classes, right? you say it's like just like creating a variable again. You store this this new object that you created. This is actually an object, right? It's a dog, and you store it inside of this variable called spot, right? And so now I want to give him a name, right? So I'm gonna give him a name as well, name and a new color, right? And one thing you can actually do is have the name of the property, right? This key, right? This property of the dog equal equal the name of the input you gave it. So this looks really confusing, but all it is let's say let's call our dog Spot, right? And we also want to make him brown, right? And this one's Clifford. He's red. Okay. So what happens is, right, we created our class, right? So now our computer knows what to do, or our compiler knows what to do when we create a new dog. It has the blueprint now, right? So when you say let spot equals, right, and then new dog, you're saying, hey, when you say new, it's like use the constructor to build a new dog, right? So it hops over to the constructor, right, stores spot inside of name, and then stores brown inside of new color. So now a name is Spot and new color is brown. So when I say this dot name, it's not the same name as here. It's not Spot yet. It's nothing. So because it's null, it's nothing. I'm gonna set it equal to Spot. So now Spot dot name is equal to the name we gave it, right? The name Spot, and the color becomes brown. And then we could also have it bark because we taught the dog how to bark. We taught it how to bark because we included it in the blueprint, right? This blueprint is this class. Okay. That's super epic. All right, we just we can create anything we want now. So if let's say you have you're playing a video game, right? You want to create a game, you can now create a player class, right? You can have it can have constructor. We want it to have a constructor, right? What the okay. And then we want to give it an x and y value, right? Where is it on the screen? You don't forget the this dot x equals 0. It starts at like the corner at 0, 0, right? You can imagine how you could use this in your code. You can now create a bunch of players, right? Or you can create, if you're creating like a zoo game, right? You could create a bunch of animals. So, and we just learned classes. Now before we review, I'm gonna do one more thing, and it's called inheritance, and it's kind of complicated, but don't worry. Okay, so I'm actually gonna use this example above. I'm gonna kind of delete everything now. Okay. Actually, no, we'll keep it. All right. So above this dog class, I'm gonna include something else. Okay. I'm gonna include a new class. I'm gonna call it class animal, right? And every animal, it has to have in constructor. Every animal has to have what? Let's give it a name, right? Every animal has to have a name and a height, I guess. Sure, that works. And then this dot name equals name, and then this dot height equals height, right? Makes sense. You can now give your animal a name and a height, right? What if we want subclasses, right? And you could think of why is it called class now? It's like a class of object. It's a type of object, right? So you could think of it as a type of some kind of it's a class of something, right? So what if we want subclasses? You want animal, right? But you also want to know how to make, a dog, right? Or a zebra, right? And you want it to have, like, the stuff that an animal has. You want it to have a name and a height, but you also want it to be kind of special in a way. So let's go ahead and try that, right? We're going to create a class of lion. So how do we give it the stuff that all animals have, right? We want all animals to have a certain thing, but we also want our lion to have a certain thing. So we say class lion extends animal. It takes the animal class and brings it further, right? So we have a constructor. And one thing that you have to have is that you have to have, if you give your animal like some properties, right, like a name and a height, you also have to give your lion those properties. You can't have, a lion not have the stuff an animal has. You can't give it, not have it, actually, I guess you can have it not have a name. But we're going to assume all animals have names here, okay? But you can't not give it a height, right? Because all animals have heights. So you have to give your lion a height too. But you also want, I guess, like teeth, or like, it has a main thickness, okay? So we want our lion to have a main thickness as well. So you can, instead of saying this not name equals name again, you're going to type in super, as in, the superclass, right? There's subclasses and superclasses. The superclass in this case is animal. When you say super, you're calling on the constructor of this superclass animal. So let me just type name and height, and then I'll explain that, right? Now you don't type in main thickness because the main is of just the line. Now you type in this dot main thickness equals main thickness. Oof. Oof. Okay. And you can also give your line a roar, right? Roar. And then, log. Roar. Right? Okay. So let's look at this, right? So let's create a new line. Lion. Let's Simba equal, new lion, right? We're going to create a lion here. We have to give our lion a name. We're going to call him Simba. Height 5. I don't know what that means. Maybe inches, maybe feet. Who knows? Main thickness of like 2. I'm just coming up with numbers here. All right. So our lion now we have a lion now. Oh, whoa. Super is only that. It's it. Subclass. Constructor. Name. What? Oh, I misspelled constructor. That's why. Okay. And I spelled main thickness wrong. Alright. Okay, fix the errors. Okay. So we have our lion now, right? And our lion has a name, right? Just like all animals, it has a name and a height. When we said new lion, Simba 5'2", what we did was we took Simba, we put it inside of name, right? That's the first argument in our constructor. Then we took 5 and put it inside of height. Then we took 2 and put it inside of main thickness. So now we have Simba 5 and 2. So we use, when we type in super, now we have, Simba and 5. We take Simba, put it inside of the constructor of our animal. So now the animal has, the animal part of our lion has the name Simba and a height of 5. And we take 2 and put it inside of the lion's main thickness. So now we can have our lion roar. And let me go ahead and type that in. Simba.roar. And it roars, right? It roars over here. But what if we created an animal? So let's, mysterious, right? It's a mysterious creature, right? It's a new animal. We call it has a name of what? We don't, or just like question marks. We don't know what it is, and a height of like 1. I guess we don't know. It's like small, but we don't know what it is. So now we have an animal, right? This mysterious animal that we don't have any any lion properties of. That's what I'm getting at. An animal won't have the properties of a lion, right? Because not all animals are lions, but a lion will always have the properties of an animal. So an example of that is to type in mysterious.roar. If we type in this, we get an error because the animals don't know how to roar. Only the lions do. So to finish this off, let me go ahead and create a new class. I'm going to call it zebra. I don't know what sounds zebra makes, actually. So constructor, again, it has to have name, height, but we can also give it like stripes, number of stripes, right? So we again have to type in name. We have to type in super to make sure that our animal, our zebra becomes an animal. It gets constructed as an animal, right? We have to call the constructor of our animal, and then we say this dot stripes equals stripes. And again, you don't always have to have the name of the input over here equal the name of your property, but it's just I feel like it's just it's just easier. And then what do zebras do? They bay? What is it? I guess they can gallop, right? Console.log room. I don't know why my zebras or just like click, right? It's galloping. Okay. So now we can say let zebra equal, or let what's the name of a zebra? Will equal new zebra. I just came up with that. All right. And then we're gonna give it the name Will, and then it's 3, and then it has 10 stripes. Okay. Oh what? Oh no. Okay. So now we have a zebra named Will, right? And the zebra again has a name and a height, just like all animals do, but also has stripes, and it can also gallop, right? So if we can't make our zebra roar, and we can't make a lion gallop, but we can, we can have them do what they were designed to do, right? So now you guys get subclasses and superclasses. All right, let's review because that was a really long lesson. All right, so, or actually it was like a medium length lesson. All right, so what is an object? Well, it's like a variable. It's just like any other variable, right? But this time it can store properties and functions, right? We can treat it like a dictionary where it has keys and the values of those keys, right? Yeah, the the keys and the values of those keys. We can also loop through objects using in instead of. This is a mess up. You're supposed to use in. Okay. Uh, yeah, it's supposed to be in. Okay, you guys get the point. And then now what are classes? Classes are blueprints for objects, right? We can essentially mass produce objects now. And I'll show you guys a good way to mass produce objects. So before we hop off. And we can also create, we can create an object using its constructor and the new keyword, right? It's our new keyword. Okay, whatever. And then we can also access the properties or functions of our object, of our class, just like of our object, by using whatever we gave it with the class. If that doesn't make sense, that's okay. So let's mass produce some animals or some zebras, right? So one way you could do that is to have for let's I equals 0, I is less than 100, I plus plus. We're going to create a bunch of lions. Yeah. So you can say let's new lion equal new lion. Equal new lion. We're going to give them all the same name. Bob, and then 1 and 1. Yeah, okay. And then why don't we just toss them in an array to store them somewhere? So we're gonna create a lions list equals nothing, and then we're gonna append these lions lions dot append, as in just stick them inside of there at the end, new lion. So one thing you'll notice here, you can access the last new line, right? New line equals 5. Oh, that's a bad idea. New line dot main thickness equals 5, right? Lines I can't append, what? Oh, it's not append, it's push, right? You push the value in. Okay. Main thickness, whoa, new line. Oh yeah, you'll notice that it doesn't know what new line is. It's because we created new line inside of this scope. So how do you actually access those lines? Well, because we store them in an array, instead of using new line, instead of using like a variable name, you access them using the index for the lines, right? So you say lines of 5 equals, or like lines of 5 dots main thickness. So now they have IDs now, like lines of 5, right? Line number 5, right? Or which is actually the 6th line, right? But okay, the point is main thickness. Let's set that equal to 5. The point is, if you store a bunch of objects in an array, you no longer need to use the variable name to access them, right? You simply just use the index for an array. And one last thing before we hop off, I want to make sure I want to get this clear. So I'm going to create one more line. Let's Ma. I'm going to name him Ma. I don't know why. New line Ma. 5 and 2, 5 and 3, sure. Okay, what if we what if you wanted to create a new line that was identical to Ma? You wanted to copy Ma. I don't like Ma. It sounds weird. Bill the lion. Okay, build a line. We have build a line. What if we wanted to copy Bill? How would we do that? Well, we could say, let's just try, in the past when we had said, 5 equals 5, and then we want to make a copy of this, we could say, let's, num equal 5, right? And so what if we, let's just log both. Now 5 and console.log num. What if we, I guess this is one way to copy it. What if we increased num? What do you think would happen here? num plus equals 9, right? You'll see that, you get 5 here, and because num is a copy of 5, you can increase it by 9, and it won't change 5. It'll keep 5 at 5. But that doesn't work with objects. Here, let me show what I mean. We're going to create a new object. Let Jimster equal Bill. Did we just create a copy of Bill? Well, let's check. Let's go ahead and log both. Oh, this might be a bad idea, actually. Let's go ahead and log their name. Dot name. Let's go ahead and log their name. I'm going to do this for Jimster as well. This is the last thing we're going to do. Jimster, okay. We have Bill and Bill, right? Makes sense. Now, what if we changed Jimster's name to Jimster? So Jimster.name equals Jimster. You'll notice that they both change. So how do we actually fix this? How do we make clones? Well, this is what people call a hard copy. Actually, I think this is what they call a hard copy. Oh no, it's not a hard copy. Okay, this is like a full copy, something like that. We have to separate them completely, right? When you do this, you're essentially making them equal to each other forever. Like they're at the same address, right? They're the same thing. So if you change one, you change the other. But what if you didn't want that? You wanted an entirely new lion, but you wanted to change its name to Jimster. But you wanted to have like the same height and main thickness. Well, here's how you would do it. Instead of saying let Jimster equal Bill, you say let Jimster equal new lion, and then you type in Jimster, and then you're basically gonna have to just type in if you don't want to type in 5 and 3, you're gonna have to type in Bill.height and Bill.main thickness. So if you wanted a bunch of fresh copies, right, of Bill, for let new lions, right? This last thing. All right, if you don't know what's going on, that's completely fine. All you need to know is that you can't make copies as easy. Less than 100. Let's create I plus plus. Let's go ahead and make a bunch of copies of Bill now. So let's lion equal new lion. Why am I doing all this? Okay, forget all that. The point is, you're gonna have to type in Bill.main thickness and Bill.height if you ever want to create a copy, right? And if you even wanted him to have the same name, you would type in Bill.name, right? So basically, you can't make Jimster equal Bill. You can't have one object just equal another object. Otherwise, they'll get like interconnected, right? Like if you change one, they'll get entangled. If you change one, the other one will change as well. So you're gonna have to create this fresh copy, a straight up just new line. And if you notice, if you change Jimster's name, it no longer changes Bill's name. So that's how you create a new a copy of an object. Okay. All right. We're gonna get into some actual cool stuff next time. I know it's kind of boring. We're just still logging stuff to the console. Nothing really exciting. But don't worry. Next week, we're gonna start drawing stuff. All right. So, thanks for listening, and I'll hopefully edit these quick. I appreciate you guys. All right. Keep on coding.